Okay, today we discuss our rest of the problem. These are also belongs to our exercise 1.2. Exercise 1.2.
Yes.
So basically, solve the following equations. Here we have the x minus 3 is equal to 4. This is, I'm doing the problem, this one. So x minus 3 is mod, and I'm telling you in previous sessions, when we reduce our mod, it will give us the two values. One is positive and one is our negative. So it will
Yeah.
gives x minus 3 is equal to plus minus 4. So from in our case, it is x minus 3 is equal to 4, and x minus 3 is equal
Fine.
to minus 4. And you know, we are moving to this side. This is
X
the
equal to 7, x is equal to -1.
yes. So this is equal to x is equal to 7. And here when we move to the, this one side, uh, so this is minus 4, this is plus 3. So this is equal to x is equal to minus 1. Okay. Solve the
Okay.
following equations, and you can do the rest of the problems like the same part in this sense. In this one, I'm just giving you this little bit clue. So this is the 2 of x plus 1. When we reduce it, so it gives plus
And
minus 7. And same for
yes,
this one and same for this one. Is there any problem from the question 5?
no problem. So should I do it now?
Okay. I will give you the time. Okay.
Okay.
So. Sketch the graph of the functions. Sketch the graph of the function. As you already know, we are put
Yes.
the values of the x, and we got the output. When we put our input, we got the output. But I'm doing this one problems here.
So,
You have,
for mod, as soon as the graph goes into a negative y-axis, you need to reflect it towards the positive y-axis, right?
yes, yes. Look at here. When we have reduced our x plus 2 is equal to plus minus y. So in our case, x plus 2 is equal to y, and x plus 2 is equal to minus y. In this manner, we have the two type of the values. One is from the positive side and one is from the negative side. So here we have the two graphs. Okay. So is there any problem? I'm going to next one problem, or I'm doing this one problem.
I understand. So you can go next problem.
Okay. Then we are moving to the this one problem. I think so. In previous session, we are also this is a cause of x. We are also have done it, and for this one, y is equal to cos of x plus 1, cos of x plus 1, and we have 0 is 0 degree is less than x is less than or equal to 360 degree. In previous sessions, in we have our domain is 0 to 180 degree, but in this problems we have the from 0 to 360 degree. So look at here, in this quadrant all is positive, and in this our sign is positive, and in this quadrant our tan is positive and our cos is positive. So in our from this one we can break it our in four quadrant. So 0 is less than x is less than or equal to 90, and you just remove it this one, and you are 90 is less than or equal to 180 degree, and for the 180 degree is greater than x is less than 270 degree, and 270 degree is less than x is less than or equal to 360 degree. 360 degree. Look at here. In this manner we have the cos is positive at here, and also cos is positive at here in the in that quadrants. Okay, so on the
Okay.
behalf of this one, our domain will be the positive on this one, and this is 272 from 360, and this is in this manner. Okay, so
Okay.
you can put the values of these one. You can do it like this type of the sorry. You can put this is the y is equal to cos of it, sorry, y is equal to cos of it. You put the 0 and 30 degree. After this, you put it 45 degree, and you put 60, and then so on forth. Okay, and this
Okay.
is you are moving to the 90 degree. This is the previous one problems. Is there any problem in question 7?
No, sir, no problem.
Okay, and don't be confused at this one part. Y is equal to cos of x mod of plus 1. So look at here. This is the plus 1. It's mean this is the extension of the graph rather than to the cos. Look at here. When we are making our function graph of the cos of x, suppose that our graph of that function is starting from the 0. So in this situation, our graph will be the starting from the 1. Why? When we put, cos 90 is what? 0. When we put it cos 90, this is 0. The graph is starting from the 0. But in this case, our graph will be the starting from the 1. Why? Because 1 is the extension of that function. And same for this in this sense. And mod is always when we reduce the mod, or when the mod is vanished, we will got the positive and negative. Okay.
Okay.
So after this, I'm moving to the next one problems uh, of this one, and then I will give you the time you can solve it and you can send it to me. Okay.
Uh,
So write down the coordinates of the their points. This is also from the exercise 1.2 problem. This is the last one problem, and these are the rest of the problems. This is 8, 9, and 10, and 11. This is our 11th part. This is first we are doing
yeah.
11th part, then we are doing the 10th and 9th part. Okay, write down the coordinates of the air points of the intersections. So in first, y is equal to mod of x, and our y is equal to 1 minus mod of x. 1 minus mod of x. Look at here. On the behalf of these two equations, can I write it? Mod of x is equal to 1 minus mod of x. Can I write it?
Yes.
Why I am writing it? Can you explain it, please?
Yes, sir. The reason is because the domain of the first mod will become the inverse of the mod function.
Yeah.
So you can write.
Yeah, but as you know, their sides are their one of them sides are same or equal.
Yeah.
On this behalf, we are writing the like this time. So if we can reduce it, or we more simplify it, this will be the move on this side. This is the mod of x is equal to 1. So this is 2 mod of x is equal to 1. So on the this of mod of x is equal to, we are dividing on the both sides by 2. So this is the mod of x is equal to what? Equal to 2. So this is the x is equal to plus minus half. Why I am writing plus minus half? Because we have the mod.
Mod.
We have the mod. So on the
Yes.
behalf of, no, I'm using that one equation. We use this one equation, or we use this one equation. This is totally up to us. But this is very simplest for, that's why we are using this one equation. So this is the x, and this is the mod of x. And when we set our x is equal to plus half, then y is equal to what? Half. So our order pair is half and half. And when we set our when we set our x is equal to minus half. So x is equal to minus half. Look at here. This is the y is equal to minus into minus of half. So this is the plus. Sorry, this is plus of plus, not plus minus. This is the plus two. Look at here. I'm just skipping the some point where you want to ask the questions. Sir, in general we have the y is equal to mod of x, and why we are writing this one. Okay. You can ask
Yeah.
me, you can ask the question, but you are not asking. Here I'm explaining you. We are writing the plus and minus, and in this session, when we have x is equal to plus and minus, so this will be this one. Okay. Uh,
Okay.
so on the behalf of this one, we have, I'm writing the order here. This is when we put x is equal to minus half, what we got, this is the plus half. And when we put plus half, and we got it plus half. Okay. So
Okay.
from this one position, we have the two type of equation, y is equal to x and y is equal to minus x, and we have the x2 values. So on the behalf of this one, we have the two values where we put positive. In positive section we put the positive value, in negative section we put the negative value. Okay.
Okay.
So is there any confusion? And again, student can make the mistakes here. There is a bigger mistake, and they can put the randomly values, but we are put the separate values, because we have the x is equal to 1 over 2 and equal to minus 1 over 2. This is the positive value, and this will be the put in positive section. This is the negative value, and this will be the put in the negative section. Okay.
Yeah.
And from the second and third part, these are the same. Can I do it, or can I move to the next one part?
Yes, you can move on to the next one.
Okay. After that, I will give you the time. Okay. So
Okay.
this is very easy part. Look at here. Our graphical representation is, so graph represent the line. So y is equal to 2 of x minus 1, and graph 2 release, sorry, related to the graph 1. Okay. The graph 1 is represent the line. So and chart I'm writing it G1, and G1 is denoted for the graph 1. Okay. And graph 2 is related to the graph 1. Okay. It's mean our question statement is what, G2 is related to the G1, and graph 3 is related to the graph 2. It's mean G3, graph 3 is related to the G2. Write down the equation of the graph 2 and graph 3. So our
Since
question is,
I
yeah,
can say since graph 1, the equation is y equals 2x minus 1.
yes,
Equation of graph 2 is y equals mod of 2x minus 1.
y, yes, 2 of x
Right?
minus 1, but why?
The reason is because we can see it's the same graph, but then the negative side, which is below the x-axis, is inverted. It's reflected on the positive side. So it will be the modulus function of y equals 2x minus 1.
Yes, this is the, okay. So this is the for the graph 1, and y is equal to 2 of x minus 1 of the mod 2. Why? Because the here this is an absolute value function, and in general we have the absolute value function is in V format. So our absolute values graphical representation is V format, but in our quadratic equations our graph will be in U format. Okay, there is a little bit
So
difference in
graph,
between.
and then for graph 3, it will be y equals mod of 2x minus 4.
2 of x minus 4. But I am explaining you the graph 2, and look at here, this is the absolute function. So absolute function always have in the v format. Here we have the in absolute we have the two function, one is positive and one is negative, and you know negative function is the inverse or image of the positive function. So look at
Yes.
here, when this is moving along this side, when this is moving along this side, so its graphical representation is like this side. Okay, now we are moving to the our
Okay.
graphical representation of the 3, and look at here. First of all, its physical appearance, or its in graphical appearance, it represents a v shape, and this is the absolute function. On the behalf of this one, this is absolute function. This is what, this is the absolute function. But what is the its graphical equation is what?
It has to be something minus 4. I know that.
Something
It has to be minus 4, sir.
minus 4. Why?
The reason is because it's a modulus function. It's a mod function, so it's reflecting whatever it is on the bottom. So if it's going through plus 4 above, it has to be going through minus 4 because it reflected after.
Mm-hmm.
It's passing through 4 after the reflection.
Okay, okay.
So if
So
it isn't a mod function, it would be going through minus.
yeah, look at here. This is our function is in our graph 2, our equation is starting from the 0.5, and this is the extension of that one, and the graph is starting from the 0.5, and in graph 3 it is starting from the graph at point 3. So 3 is the extension of that one function. So on the behalf of this one, what is the representation of the that one function is?
Could you repeat again, sir?
I'm asking you, what is the graphical representation of the that one function when we have the extension is, when we have the extension is 3?
Um, y will be increased by 3, so you multiply the entire thing by 3.
Yeah, look at here. So
It will
this
be
is,
6x
yeah,
minus.
yeah, look at here. Why I am writing it, because 3 plus 3 is the extension. Same for the previous one problems where we are. This is already we are discussing like this type in cause of that functions. Look at here. I'm explaining you it in this manner. When we have cos 90, this is a 0, but plus one is the extension, and shift plus 1 is the extension are shifted to the 1 point. Okay, so in this
Yeah.
manner, in this manner, look at here, our graph is starting from the 3. It's mean our same equation is what, 2 of x minus 1. Here this is the single line straight line, that's why this is the 2 of x minus 1. But when we are seeing that this is the v type shape, this is the absolute function, so I'm putting it absolute for the we are not writing the equation of that one function. So this is the and this is 2 of x minus 1, 2 of x minus 1, and same for the mod. And but this is the from the 0.5, and this is the 0.5. The origin is same in graph 1 and graph 2, but in graph 3 this is a shift from 0.5 to 3 points, and this is moved to the upward side. This is moved to the upward side. That's why I'm writing the plus 3. And suppose that our graphical representation is our graphical representation is like this type, move to the downward. So in this manner we are writing the equation, graphical representation of that equation is in this manner is minus 3. Why I am putting the minus 3? Because it moves downward, it moves the along y-axis, but in downward. When it moves to the upward, we can add it, and we can count the points, how much points the graph is shift or shuffled or shift from that point. If it moves the 4 points, we write it plus 4. If it moves to the downward, and we write it plus 4. Okay,
Okay.
so is there any confusion?
No confusion, sir.
Okay. Is there any thing is I think so there is anything played from your side?
Everything's case. I can do some solves.
Okay. Okay. Then we are moving to the next one problems. Look at here for the ninth one part, the graph of the that part of the quadratic curve and its inverse. What is the equation of the curve? So what is the equation of the curve and what is the equation of the inverse function? So in this in our ninth part, in our ninth part, what we are trying to find, we are trying to find the equations, find the equation of the equation of the inverse and the curve, inverse of the and the curve for the q ninth. This is so q ninth is like this one. Assume the equation. Since it is a quadratic with the turning point at the origin, only the right hand bounce is shown. Look at here. We are in the first quadrant, and this is in positive, and this is our equation of. Look at here. This is our equation of the curve line, and this is also its inverse. This is also its inverse. So in since it is the quadratic with its turning point at the origin, so this is the y is equal to m of x plus c square. Can you know about this one equation?
Y
Y
equals
is,
mx plus.
yeah,
No, so I
m.
don't.
Okay,
I'm expert.
okay. C is our intercept form of the y. I'm explaining
Yeah.
you. Intercept form of y, and m is the slope. In derivative you are finding the slope line tangent, you are finding the derivative of the equation. Basically you want to find the slope of that one equation, but in before of the derivative we are finding the slope like this type of the equations. Okay, like this type of the equation. So here y is equal to so from this one only in right hand branch, this is the generalized equation. Basically this is our generalized equation, but y is equal to x square plus c, x square plus c. Why I am writing in this is only the right hand branch, it is shown there. So on the behalf of this one, look at here, this is 1 and 2. Our 1 is what? This is the our slope. This is 1 is our slope, so m is equal to what? So basically m is equal to 1. Why m is equal to 1? Because our point is, look at here, our point is what? 1 and 2. 1 and 2. So y is equal to m replace 1 x square plus c. So this will be the equation is like this type of the format. Okay. So on the behalf
Yeah.
of this one, we are using the this one equation. So our quadratic our pair is what 1 and 2. So this is x is 1 and y is equal to 2. Y is equal to 2. When we are putting this is 2 is equal to 1 plus c. So c is equal to what? C is equal to 1. C is equal to 1. So this equation will be the change like this type format, or we are using the generalized equation. So y is equal to, m is equal to 1 and c is equal to 1. So this is x square plus 1. Can I write it? Can you understand it?
Yes.
Okay. So on the behalf of when we are moving from this point to this point, when we are moving to the from this point to this point, our point is what? 2 and 5. So x is equal to what? 2. So y is equal to 2 of square this plus 1. This is equal to 5. This is equal to 5. So it means that the graph is, it means that now we are checking the second point. So basically we are checking the second point, or we are moving to the point one, from point one to point two. Okay.
Yeah.
After this, what is the equation of the inverse? So what is the equation of that inverse functions? So y is equal to, x square plus 1. There is nothing hard for you to finding the inverse. We are already discussed it, y minus 1 is equal to x square, and you take the under root of both sides. So this is the under root is equal to what, this is the plus minus 1. So here and under root cancel, x is equal to plus minus, replace it y minus 1. And our last step is what, x is replaced to the y and y is replaced to the x. So plus minus 1, this is the x minus 1. Okay.
Okay.
So understand? Is there any confusion? Look at
Could
here.
you?
Yeah.
Yeah.
Look at here. We are working in the first quadrant. Look at here. We are working in the first quadrant, not in the second quadrant. So in first quadrant, all quantities are positive. So on the behalf of, since the right hand branch of the parabola is shown as, so y is always greater than or equal to 0. It is greater than or equal to 0. So we take that x minus 1 under root of plus. Why I am writing it? Because we are in the first quadrant.
Yeah.
In first quadrant. Can you please stop that TV or reduce your sound from the background?
Okay. Yes, sir. I told them to reduce it.
Okay. Okay. Can I move to the next one part, please?
Okay.
Okay, look at here. If we have y is equal to 1 minus 2 of x, y is equal to 1 minus 2 of x. Look at hat here. We have the y is equal to plus minus 1 minus 2 of x, or we are writing it 1 minus 2 of x, and y is equal to minus into 1 minus 2 of x. So this is equal to 2 of x, and this is the minus 1. Okay. So when we have working on this one side, where we have working on this side, our on the positive side. So this is on the positive side. We are setting x y is equal to 0. Y is equal to 0 because we are working in the positive quadrant. In first quadrant, set let 1 minus 2 of x is equal to 0. Why I said? Because we are working in the first quadrant. We are working in the first quadrant. So x is equal to half. So x is equal to half. So on the behalf of this one, x is equal to half, we are setting the 0. When y is equal to 0, x is equal to half. Okay.
Yeah.
And then we are moving to the downward side or negative side, or from the negative side. And what we are doing the in the negative side, this is the 2 of this is 2 of x minus 1. So on the behalf of this one side, what we are doing, look at here, but here we have the already we know that our equation is in previous we are using y is equal to m of x square minus 1, and our main general equation is what, 1 minus 2 of x, so m is equal to minus 2. And on the behalf of this one, we are comparing this equation and this equation, so m is equal to minus 2 and c is equal to 1. Okay, c is equal to,
Okay.
or y-intercept is equal to minus 1. Hmm. Can you got it?
Yes, I understand. I'm following.
Okay. After this, when we are on the negative side, when we have the on the negative side, this is the 2 of x, this is the minus 1. This is 2 of x and this is minus 1. How you can solve it? Because this is our negative side and we are setting the points from the negative side, and we can do this one, okay, in the same manner. Okay.
Yes, sir.
Okay.
Yeah.
After this, we use the series of the transformations to sketch the graph of that function. Okay, this one is very easy, and basically I'm doing this one problems. This is our we reduce our absolute function, and here we have the absolute function. It's mean we have the two type of the function. One is positive and one is negative, and you can simplify it. Simplify it. This is very easiest function. I'm giving you the some clue point of this one functions, and after this you can do the sum of the problems. Okay.
Yeah.
So this is the y is equal to 3 of x plus 1 minus 2. It's mean you have the 3 of x plus 1 minus 2, and you have a y is equal to minus into 3 of x plus 1 plus 1 minus 2. So this is equal to, 3 of x minus 1. This is, and y is equal to minus 3 of x minus 1 and minus 2. So y is equal to what? Minus 3 of x minus 3. You can set the points in the x, and here you have the order pair, and in this manner you have this one, and this is the our linear equation. So uh, this will be the graphical representation of that functions are in straight line, because this is the linear equation, not in the quadratic equations. Okay.
Okay.
So is there any confusion from this one problems? So basically
No.
today we discuss our the exercise. Basically we have the 1.2 exercise, and with this one we are ending our chapter 1, but tomorrow we will do our the examination part. But before of this one, you are doing the some problems here. I'm assigning you. Okay. But today we have finalized our exercise 1.2, as already we solve our exercise 1.1, and today we are ending our exercise 1.2. And is there any problem from the exercise 1.1 and 1.2? You can ask it to me. But before this one, you can do the from this one, you are doing this one part, and you are doing this one part. Okay.
Okay. I'll do it. Okay, so 5D, right?
Yeah.
Okay.
Mm.
X equals 0, x equals minus 4. Very 5D.
Okay, okay. And now you are moving from the 6, and you are doing this one, and also this one, and also this one.
Which one, sir? I can't see it.
I'm telling you the question 6 for A, B, and C.
I'm doing all three, right?
Yeah.
Okay, I'll do it. I need give me like a bit more time because I need to draw the graph. That's why.
Okay. Okay. No issue.